Good day, viewers all over the world. We want to continue our deliberation on further examples on calculus. Further examples on calculus. Of course, I have so many videos on calculus, starting with differentiation, the limit of a function, differential calculus, that is differentiation. So many videos on differentiation, applications of differentiation. Then we have videos on integration and applications of integration. We just want to consider about 3 examples on calculus, like what we have on the board, where the question says that we should determine, the question says that we should determine the rate of change. We should determine the rate of change of voltage given V is equal to 5t, given V is equal to 5t, given V is equal to 5t sine 2t when t is equal to 0.2 seconds. So that is what we are asked to do. So we are asked to determine the rate of change of voltage. Rate of change of voltage given V is equal to 5t sine 2t when t is equal to 0.2 seconds. So what do we do here? We are given V. What is V? V is given as 5t sine 2t. V is given as 5t sine 2t. That is V. Then, how do we get the rate of change of voltage? That will be dV dt. 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 So what do we do here? That will be dV dt. We are going to differentiate V with respect to t. We differentiate V with respect to c. That is, we have dV dt. So if we do that, of course, we are going to apply product rule here. 5t, then sine 2t. 5t, then sine 2t. If I pick 5t, I'm going to differentiate sine 2t. Sine 2t will be 2 cos 2t. Then plus, I will come back and pick sine 2t. Then I will differentiate 5t. If I differentiate V with respect to t, 5t, I'm going to get 5 there. Then from there, we are going to have 2 times 5, that will be 10t cos 2t plus 5 sine 2t. So that will be the rate of change of voltage. But we have to find this rate of change of voltage when t is equal to 0.2 seconds. That is, when t is equal to 0.2 seconds, what would be the value of dV? dV dt, when t is equal to 2.0 seconds, dV dt will now be equal to, wherever we see t there, we substitute the value of 0.2 seconds there, will be 10 into bracket 0.2 seconds cos 2 into bracket 0.2 plus 5 sine 2 into bracket 0.2. That is what you are going to get. That is what you are going to get. Then from there, we are going to expand. That is, we are going to have, this will be 2 cos 0.4 plus 5 sine 0.4. So we'll look for the value of cos 0.4 and sine 0.4. So what is the value of cos 0.4? We are going to look for the value of cos 0.4 and sine 0.4. That's what we are going to do. So we look for the value of cos 0.4 and sine 0.4. Then this is going to give us 2. What is cos 0.4? Cos 0.4 will be 0.9211. Then plus 5. Sine 0.4 will be 0.3894. 0.3894. That's what you're going to get. Then we do the multiplication. So 2 multiplied by 0.9211 is going to give us 1.8422 plus 5 multiplied by 0.3894 will give us 1.947. So if we add these two together, we are going to have 3.789. So the rate of change of voltage the rate of change of voltage when t is equal to 0.2 seconds is 3.789. That will be the rate of change of voltage. So that will be the rate of change of voltage when t is equal to 0.2 seconds. So this is one of the application of calculus. So this is the first example that we're going to consider on application of calculus. Just follow the step wisely, then there won't be any cause for alarm. When we talk about the rate of change, simply means change, rate of change of velocity with time, the v, the t, and rate of change of voltage with time, the v, the t, and that is what we have. Done, and we're able to get the value. So we take another example. Say example 2. Let's take another example. Say example 2. In this example 2, we are asked to determine the gradient. Of course, gradient is same thing as slope of the curve. Gradient of the curve y is equal to 5x all over 2x squared plus 4 at the point root 3 all over square root of 3 over 2 at this point. This is what you want to do. So in this case also, we have to determine the gradient of the curve. This is the curve. So how do we get the gradient? The gradient will be slight change in y all over slight change in x. That is gradient is the same thing as slope. So how do we get the gradient in this second example? How do we get the gradient? That is what we are about to do now. How do we get this gradient? Of course, y is given as 5x all over 2x squared plus 4. That is why y is equal to 5x all over 2x squared plus 4. That is why. So what do we do here? What do we do in order to find the gradient? What are we going to do here in order to find the gradient? So what we have here is fractional. So we are going to apply quotient rule. We apply quotient rule to be able to solve this. We are going to apply quotient rule to be able to solve this problem. We are going to apply quotient rule. So how do we apply quotient rule here? Quotient rule by formula. If you want to find the gradient here, the y dx will be v the u dx minus u the v dx, everything all over v squared. That's what we are going to apply in order to find the gradient. So when we apply the formula, what do we get? From this formula now, it shows that this is u, the numerator is u, while the denominator is v. The numerator is u, the denominator is v. The numerator is u, the denominator is v. So what do we do here? We are going to find u is equal to 5x. So we are going to find the value of the u dx. The value of the u dx here will be 5. Then v is equal to 2x squared plus 4. We find the value of the v dx. The value of the v dx will be what? 4x. That is what we are going to get. So the gradient now, we are going to substitute the value of u, v, the u dx and the v dx into this formula, into this given formula here. Okay, which will say the gradient. So if we do that, what do we get? We now say the gradient given us dy du, dy dx will now be, what is v? V is 2x squared plus 4 into bracket the u dx. What's the value of the u dx? The u dx is 5 minus u is 5x into bracket the v du. The v du is 4x. Okay, everything all over 2x squared plus 4 all squared. That's what we are going to get. That's what we are going to get. So if that is the case, then let's do the substitution. And let's cancel that. This 5, this is going to give us 10x squared plus 20 minus 20x squared all over 2x squared plus 4, everything all squared. Then 10x squared minus 20x squared. That will give us, here we are going to have 20 minus 10x squared all over 2x squared plus 4 all squared. So the value of x is given us, at that point is given as square root of 3. So wherever we see x there, we are going to substitute value as square root of root 3. So if we do that, if we substitute x equal to square root of root 3, we are going to have 20 minus 10 into bracket square root of root 3 all squared all over 2 square root of 3 all squared plus 4 everything squared. This will cancel this. This will take care of this. Okay? At the end of the day, we are going to have 20. This is 20 minus 10 times 3 is 30. So 20 minus 30, that will be minus 10. All over, yeah, 2 times 3, 6. 6 plus 4, 10. 10 squared is 100. This will cancel this. At the end of the day, we have to do minus 1 all over 10. That is what we are going to get. So our final answer will be minus 1 all over 10. Then what do we do here? What do we do here? We say the gradient. The gradient, we say the gradient of the curve. The gradient of the curve at the point root 3 all over root 3 all over 2 is minus 1 all over 10. That's what we are going to get. That is what we are going to get. If we apply it, then that's what we are going to get. We are going to get the gradient as minus 1 all over 10. So we've gotten the value of the gradient. So that is what we are expected to do. So we have taken 2 examples on differentiation. So let's take one more example on integration under further examples on calculus. So by the time we take this example 3 will be the example 3 will be on integration. So the example 3 will be on integration. So let's solve this example 3. The example 3 will be on integration. Example 3 will be on integration. So that is what we're about to do now. So let's write out example 3. Example 3. Example 3. In this example 3, we are asked to evaluate integral 1 to 3 5x square root of 2x squared plus 7 dx. So this is what we have to do. We have to integrate. This is what we have to do. So how do we approach this? That's what we're about to do. So let's look at it. How do we approach this problem? Of course, what we have on the board, we are going to apply integration by substitution to be able to solve what we have on the board. We are going to apply integration by substitution. And by implication, the 1 and 3 here, they are value of x. This is the lower bound and this is the upper bound. So how do we solve this? Integral 5x square root of 2x squared plus 7 dx. 3 and 1. So we say let u equal to 2x squared plus 7. So that by the time we differentiate du dx, we are going to get it to be what? 4x. So we've represented everything in this as u. So there's need for me to make du the sum of the formula. So this du dx. So what will be the value of dx? Dx will not be equal to du all over 4x. This value 1 and 3 are values of x. But if we decide to rewrite everything in form of u, it is compulsory for us to now find the value of this bound in form of u. Okay? When x is equal to 1, this is the lower bound. What is the value of u? We represent u as u is something as what? 2x squared plus 7. So when x is equal to 1, u is equal to 2 into bracket 1 squared plus 7, and that's 9. So when x is equal to 3, u will be equal to 2 into bracket 3 squared plus 7. 3 squared is 9. 9 times 2, 18 plus 7, that will be 25. Okay? That is what we are going to get. So what do I want to do now? I want to rewrite this, what we are given, in form of u, so that the lower band here, instead of 1 now, in terms of u will be 9, while the upper band, instead of 3, in terms of u will be 25. That is, this is what I'm trying to say. That is, I want to say that integral 5x square root of u will let u to be equal to this. Then what is ds? ds will now be du all over 4x. Okay? Then instead of 1 here now, in form of u, it will be 9. Instead of 3, in form of u, it will be 25. So x will cancel x. If x cancels x, what do we have left? Let's look at If x cancel x, we have 5 1 over 4. We can bring it out. Integral 9 to 25. Then square root of u is same as use half du. So if we integrate this, what do we get? If we integrate what we have here, we have 5 1 over 4. If we integrate u plus, that will be u plus 1. That will be 3 over 2 divided by 3 over 2. So if you change it, that will be 2 over 3. That will be multiplied by 2 over 3. That's what you're going to get. 2 here 1, 2 here 2. Then from 9 to 25. At the end of the day, we are going to have 5 over 6 u raised power 3 over 2 from 25, 9 to 25. Then here we are going to have 5 over 6 into bracket. When u is equal to 25, we are going to have 25 3 over 2 minus 9 3 over 2. So what do we get from there? We have 5 over 6 into bracket. I can rewrite this as 5 squared multiplied by 3 over 2 minus 3 squared multiplied by 3 over 2. That's what we get. This will cancel this. This will take care of this. Okay? That will take care of. So that was going to take care of this. At the end of the day, our final answer will now be 5 over 6 into bracket 5 raised power 3. 5 raised power 3 minus 3 raised power 3. That will be 5 over 6 into bracket 125 minus 27. So what is 125 minus 27? We have 5 over 6. That will be multiplied by 98. Okay? That will be multiplied by 98. Can 2 divide this? Yes. 3. 2 here, 49. 49 times 5. 49 times 5. If you use 49 to multiply 5, that will be 49 times 5 will be 245. So we have it to be 245. 245 divided by 3. Then this same thing as how many times we take? That will be 81 2 over 3. That will be the final answer. So the final answer will be 81 2 over 3. So that will be the final answer. So I want us to go through all these 3 examples under further example on calculus. So let's go through it. Let's go through everything. If you have any question, just comment. Just write it at the comment section. I promise to attend to it. So I'd love to stop the class now. Then we continue from there. Thank you.